Hi everybody, this is Eugene O'Loughlin lecturing computing at the National College of Ireland, and welcome to my series of short how-to videos. In this video we're going to learn how to perform simple linear regression, and we're going to do it by hand. So before we start, let's take a look at the sample data that we're going to use. My first set of data are the number of questions correct out of a possible 20 that 10 of my students have taken in a test, and I'm going to designate these as my X values. My Y values are each individual student's attitude by percent to taking tests. So the higher the score here, the higher their attitude, or more positive their attitude to taking tests is. What I'd like to be able to do is to use simple linear regression to be able to predict a student's attitude, Y, given a value for their score in the test, X. When I plot these two values against each other here, I get a chart like this one drawn in Excel. I've got my attitude on my y-axis and the number of questions correct on the x-axis here, and each dot represents each of my 10 students and plotted where they are on the chart here. The line through the center here, this is my regression line, or trend line as it's called in Excel, and this tells me what the relationship is between my variables. So what I'd like to be able to do, for example, say I have a value here of around 15, what would the corresponding value for y, my attitude, be? So in order to be able to predict like this, I need to use my regression formula. These are the formulas that I'm going to use. My linear regression function is y, which is my dependent variable, is equal to a, which is the y-intercept, plus b, which is the slope, times x, which is my independent variable. So if I know the y-intercept, and that is if I take a ruler here, and if I continue the slope of the line here, if I continued my regression line, where on the y-axis would it cross? What would the value be here? So that's going to be my y-intercept, and that's represented by the letter A. And the letter B then is the slope of this particular line. So in other words, if I know my value for the slope of the line and the y-intercept, I can then, using a given value of x, predict a value of y. So there's two pieces in here that I need to know before I can use regression for prediction. I need to know the slope of the line, and I need to know the y-intercept. The formula for the slope of the line is as follows. The slope is represented by the letter b, and it's equal to r, which is Pearson's correlation coefficient, multiplied by the standard deviation of y divided by the standard deviation of x. So there's a fair bit of calculation involved here, but as we'll see a little bit later on, there are many shortcuts that you can take. Once you know the slope of the line, you can then calculate the y-intercept. It's designated by the letter a, and that's equal to the mean of the y sample minus the slope times the mean of the x sample. So once you know b, the slope, calculating the y-intercept is relatively straightforward. So the order which I'm going to do things here is, I'm first of all going to determine the slope of the line b using Pearson's correlation coefficient and the two standard deviations. Now in an earlier video I showed you how to calculate the correlation coefficient r using the formula here on the left hand side. So if you'd like to learn how to do this, it does take a little bit of time. Click on the link on the video that's appearing on your screen now to show you how to calculate Pearson's correlation coefficient r by hand. In brief, these are the same sets of values as I had before for the numbers of questions correct and the attitude to test scores. And I've calculated the mean of each of these. So the mean of x is 15.6 and the mean of y is 79.7, which, as we know, we will need a little bit later on. And to work out my values to plug into the OR equation, I've taken the each value of x minus the mean, multiplied it by each value of y minus the mean of y, and summed all those values up. I also have the sum of x minus x bar squared for all values of x, and the sum of y minus y bar squared for all values of y. So these are my summed values here. And they were plugged into my regression formula, my correlation formula over here, and gave me a correlation coefficient r of 0.596, which is a moderate to strong positive correlation. So now I'm ready to start my calculations that I need for my linear regression. The first thing I needed was the formula for my slope, which is designated by b, and that's equal to r times the standard deviation of y divided by the standard deviation of x. So we can plug in the value of r straight away here, so that's 0.596, which we've already calculated. So that's equal to 0.596 multiplied by, and we need to take the standard deviation of y and divide it by the standard deviation of x. So let's figure out these here first. my formula for the standard deviation of y is equal to the square root of the sum of y minus y bar squared divided by n minus 1. Now, that can look a little bit of a mouthful, but the good news is you've already got these figures here. The sum of y minus y bar squared is the sum at the end of this column over here. You've already got a column for y minus y bar squared, and we've summed up all those values. So that's going to be equal to the square root of this value here, 1206.1, 1206.1. And we're going to divide that by n minus 1. We have 10 sets of values over here, so that's going to give us a value of 9 in here. So let's work this out. 1206.1 divided by 9, and that's equal to 134.01, and I'll take the square root of that, and it gives me a value of 11.576 rounded. So the square root, so the standard deviation of y is equal to 11.576. So let me put that in my formula over here. 11.576, and I want to divide that now by the standard deviation of x. So let's do the same thing here as we've done before. Standard deviation of x is equal to the square root of x minus x bar squared divided by n minus 1. We've already calculated the sum of x minus x bar squared. This is the column for it over here. And there's my value there. The sum of x minus x bar squared is 42.4. So that's going to be equal to the square root of 42.4, once again divided by n minus 1, which is 10 minus 1, gives us a value of 9. And so let's work that out here. So 42.4 divided by 9 is equal to, oops, I did that twice. 42.4 divided by 9 is equal to 4.71, and I take the square root of that, gives me 2.171. So I can put in 2.171 over here. So now I'm ready to just work out this formula here. So 0.596 multiplied by, let's do the fraction here, 11.576 divided by 2.171. That's equal to 5.332. And let me multiply that by 0.596. That gives me a value of 3.178 rounded. So my value for b, the slope of my line, is 3.176. Now I'm able to go and calculate the y-intercept. Remember, the y-intercept designated as a, that's equal to the mean of y minus the slope times the mean of x. Now, we've already got some of these values here, so let's plug them in. The mean of y is, I've got it over here, which is 79.7, minus b, which I've just calculated, which is 3.178, multiplied by the mean of x, which is 15.6. So let's do the calculations here. So first of all, I'm going to do the multiplication. So 3.178 multiplied by 15.6 gives us, that's going to be 79.7 minus 49.577 rounded, which is equal to 79.7 minus 49.577. That gives me a value of 30.123. So my y-intercept is a value of 30.123, and my slope of my line is 3.178. So now I'm ready to use the simple linear regression formula. Just a reminder of what that is again. So that's going to be y is equal to a plus b times x. I can plug in my values here straight away. So that's going to be equal to a, which is 30.123, plus b, which is 3.178 times x. So now if I'm given a value of x, I can work out a value of y. So supposing x is equal to 15, so that will the y then will be equal to 30.123 plus 3.178 multiplied by 15. And when I work that out, let me do that in the calculator here. So 3.178 multiplied by 15 that's 47.67, plus my 30.123, gives me a value of 77.803. So what this tells me then is, if I have a value of x of 15, using my simple linear regression formula, in which I have the y-intercept and the slope of my line, plug in my value of 15, it tells me that my value of y will be 77.803. So if I go back to my chart here, I can see that if a value of 15, I go up to here and work my way across, I'm getting a value very high 70s, just below 80 over here, so it's approximately correct according to my chart here. So that's how you perform simple linear regression by hand. I hope you found this video useful. Thank you for your attention.